morning. I like to say good morning because we've come back after the lunch break and this is the time where everybody is sleeping. I used to have my thermodynamics class in engineering. I used to always sleep at this time. So I go with the logic wherein I tend to talk a little bit less on the slideware because since morning you're just seeing slides. And the two words you're seeing is eBPF, XTP and TC. I will keep that aside. I want to show you what this particular thing does. Okay. Now going back in time, right, if you look at the use cases that people had, right, so I come from a background wherein I started off on the telecommunication side of things and then moving across gradually to networking, switching, and then cloud, security and whatnot. If you look at the way the use cases have sort of diversified, right, people have looked at the aspect of doing things on the telco side. They've moved into virtual network functions and whatnot. That was sort of the play that people had. Now what has happened over a period of time, that thing has changed. It has moved into different form factors that people want to deploy into. People started off with virtual machines. That was a big thing, very big thing at that particular point of time. And then came across the concept of containers. That's where everything just, exploded. People wanted to do things at a very rapid pace, good pace, fast pace. But what actually ends up from the developer mindset is how good should my code be? But if you look at it in production, right? In production, what you are looking at from a customer perspective is when you hit something, right? Or as they say in English, when the shit hits the roof, right? How do you troubleshoot? How do you triage that particular issue? How do you isolate it? Now that is broken down into three specific pillars as of today. Keep aside the cloud native part because people keep talking about the cloud native part, but you've also got to look at the fact that a lot of infrastructure is still sitting on-prem. That could be your data centers, that could be VMware's, physical x86 boxes and whatnot. But three pillars always stand out: networking, security, observability. Networking, how do you connect? How do you secure that? How do you observe when both of them are in for some problem? Having said that, Isovalent, we are the creators of Cilium and eBPF. Isovalent is the company, meaning the founders and the co-founders, Thomas Graf, Dan Wendt, Liz Rice. You'll hear a lot about these people. They were the ones who started Cilium along with other people as well. You've heard of Brent, you heard of a lot of other people. Anthony is there and a lot of other guys as well. If you look at the sort of the contributor side as well, right? If you look at people who've adopted it, this is just a very small list. There's a massive amount of people who've gone ahead and adopted Cilium as such. If you look at it, and I'll talk about the fact that what has actually sort of taken them into this particular path. When you look at the container world, right, it was all about how do you network. So you needed some sort of an interface. That's where the word CNI was coined. It was the container networking interface, because previously you would always look at something like, two routers, two switches connected via either, some Ethernet in switches, some sort of a serial link, something being connected via fiber, something being connected. But in the format or the world that we are living in, it requires something which is scalable, which is fast, which is dynamic. That's where Cilium came in the picture. Cilium uses eBPF. That is where the entire picture started from. And these are some major use cases we plan to solve. Today, I just want to keep it like this, talk about the architecture concepts. What are the networking concepts around it? Tetragon and observability. If you break down the sort of the silos from the product perspective of Cilium, you look at networking, you have security. This is where this particular product comes in, Tetragon. And then you have something for observability. That is where another product comes out. It's called Hubble. It's not the Hubble telescope. I mean, we've put the icon as Hubble, but that's what it's all about. I'll take a pause here. If you look at the classical, like I think Santosh just mentioned that word about tuple, right? If you look at a tuple, a 5-bit tuple, it's source IP, source port, dest IP, dest port, and proto, right? That's where the entire networking world has been sort of constrained into. But come this, we sort of took a different approach to it. We took an approach where it should be all about identities. If you look at, I'll give you an example. If you go to an airport today, right, when you're entering the airport, what happens? And I'm just sort of moving away from networking for 1 second. If you are entering into an airport, right, what's the first thing that you head into? You are sort of into a particular gate, he checks your passport, he checks your, let's just keep international travel, let's say domestic travel first. He checks your boarding pass, your name is there, matches it with a particular ID, right? Matches the ID, then he looks at the fact, okay, is this guy actually going for a flight which is slated for today? Then what does he check? How many people are going on? That is where you are actually looking at a security parameter, right? That is where a normal use case starts in. Now, if you sort of put the concept of IP addresses, source ports, that's where things start getting convoluted. That's where Cilium took a leaf out of it. And then we said we will only deal with identities. We will look at identity mapping rather than looking at IPs. Because what happens after IPs, I'll come back to this, is something very familiar you must have seen. This word, IP tables. Have you heard of IP tables? If you load up a Linux box, right, that's the first thing you'll probably see, right? Now what happens, if you start adding services, more and more, the IP table just keeps getting longer and longer and longer, because it's just relying on that word, IP. We don't want to do that. We don't want to deal with that. So eBPF is the concept of identities. You're looking at identities. The moment those identities are getting added, they're getting removed, there is a path that we are stitching together. We call that as an endpoint list that we are maintaining internally. It gets updated dynamically, whatever be the use case, be it networking, be it security, like you've created an L3, L4 policy, you've created an L7 policy, whatever it is. It's just based on identities. Just go back. This is something which I think you guys have been hearing since morning, so I don't want to talk about it. What JavaScript is to the browser, eBPF is to the Linux kernel. Very simple. Some very basic groundwork. So if you look at from a perspective of how you need to bring up from a Cilium perspective, right? So you have the 4.19 plus kernel. You need to load that up. The good part is you're not restricted. Now there are two aspects when you look at Cilium and look at Isovalent, right? Cilium is where the open source side of things come in. Isovalent is where the enterprise side of things come in. You have feature sets which are available in open source. You have features which are available in Isovalent as well. There is a demarcation when it comes down to enterprise versus the open source features. But the good part, when you want to go across and deploy features on Cilium from an open source perspective, right? Let's say you have something like a kind cluster, a CubeAtom cluster, a K3s cluster. You want to do it on your own laptop with Minikube, with anything. You can just spin up Cilium in probably a fraction of minutes. It's not even, it's going to take you, hours. You can do it in minutes. I'll be walking through that in the next session as well as to how you can do that. Next comes the part, is this the only way where Cilium can go? No. When it comes down to adoption by cloud, Cilium is the default CNI in Azure, in Google, as well as in Azure. So when their clusters boot up, right, AKS or EKS or GKE clusters boot up, Cilium is the default CNI. Yeah, this is something that we've already talked. I just skip this one. Yeah, so this is one thing. So it's a per CPU hash table, which is highly performing rather than something which is totally linear. And the moment you add something, you've got to, from an IP tables perspective, all rules have to be replaced from a perspective of being like a massive giant scale which just starts offloading services. What do you get with Cilium? So if you look at, like I talked about 3 pillars, right? You're looking at networking, observability, and then you're looking at security. You're looking at all these feature sets. You have network policy, you have encryption. You want to do like an IPsec or a WireGuard. You want to do a pod-to-pod or a node-to-node encryption. Load balancing. You want to do classical north-south or east-west load balancing. You can achieve that. You want to do all of these features. Like say you have FR. Sorry, go ahead. No worries. You want to use BGP to go across and talk to your top of the rack switches. You can use that. When it comes down to a service mesh, you can use ingress. You have an ingress which is going across and punting traffic back to your backend pools. You can use that. You can use mutual TLS. From an observability perspective, One part is looking at your own UI, which is provided by Cilium. Other part is exporting these particular metrics or logs to third-party SIEMs, which could be Prometheus, Grafana. You have cloud-based, exporters. Anything you can do that. Sure. Yeah, you mean? When you say why, in the sense that what do we do about it? Yeah, we do it. I mean, that is something which is native when it comes down to networking. So when it comes down to like jumbo or jumbo frames or packets, or in terms of encapsulation, I can also add that when you look at the word overlay, right? And I'll come to your question. It's just not pure overlay. If you, let's say in a cloud provider environment, right? They do not want to run an encapsulation type, be it Geneva or VXLAN. It could be their own native routing, right? So that is supported. But apart from that, there are use cases where people want to do VXLAN or Geneva. That's also supported. Now, having said that, from your perspective of fragmentation, if you bring up today any cluster in EKS as an example, I'll give, right? The default MTU it comes up with is 9001. But if your application is sending packets which are not going to be accepted, it will get fragmented. Cilium runs as an agent on top of every node that you are going to spin up. That's going to take care of that. Other features that you must have heard of today, right? AFXTP, node port, whatever. All of that is supported. All of that is supported. And that's not something which is available in the enterprise version. That's available in the open source version. Like I said about the architecture, right? So if you see here, right, this is a worker node, right? So Cilium agent is running on top of it. It's, doing that particular call, and sort of, all your particular feature sets that are there, totally completely available. This is a sort of a detailed view. So you have Cilium agent which is running here. You have your Cilium CNI, your Kube API server. That code. This guy is its job is to go across. Whenever you spin up, and I'll show that in the demo. Whenever you spin up a particular cluster, right, you'll have this guy doing a job of doing all the. You've heard of the term garbage, right? It does all the garbage cleanup in terms of API calls. Making sure no sort of IP address allocation is getting messed up or whatever. This guy's job is that. And then it's going across and talking, because what happens is, when you are looking at something being done inherently on your particular bare metal, you will run an IP address module by yourself. But when it comes down to these guys in cloud, they have their own IP address modules. Somebody has to talk, so that's where this guy does. But the main job is Cilium agent that is running on each of a particular worker nodes. So let's say you have a cluster that you create, right? You have 3 nodes, you'll have 3 Cilium agents, one running on each node. Yeah, that's all. That's exactly what it's talking about. And I'll just take just go back here just to explain one thing. Probably, I think I have a slide later, then I'll just call over that. Actually, here itself. It is here, probably missed here. So let's say you have 2 specific clusters. One cluster which is your data center cluster, and you have something which is sitting somewhere in Azure or wherever, right? And you have workloads which are behind that. You want them to talk. You can easily achieve that. How do you achieve that? Using something called as cluster mesh. So basically you create a mesh across which, and then comes the part, do you want some specific certificates? So you use etcd. Using etcd, you can validate those particular certificates that, okay, this guy's request that is coming in is actually validated, and then you can go across and talk to a particular database or whatever that use case may be. Is it okay now? Sorry, this is a question. Yeah, this one. I've heard of the name, but I don't know about this. But to be honest, I don't know about that particular, but maglev is something, yeah, it's an algorithm. That was actually developed by Google. That was developed by Google, right? So from the perspective of this and this, right, when it comes down to the cloud, right, there are specific, I can say, nuances when it comes down to doing load balancing. If you look at Azure, right, it does not support IP encap itself. So now in that sense, maglev is where you can use that particular sort of load balancing technique to go across and spray those packets across. Similarly for DSR, direct server return, right? This is applicable either on bare metal or on specific cloud platforms as well. So there's no specific reason as to the fact that we've not included that, but these are some of the ones that I've actually highlighted. There are plenty of more options that are available with Cilium. And the best part, sorry. It's our own stack. So basically we have sort of picked up a module from GoBGP, and we are running it on our stack. If you look at from a full-blown BGP perspective, let's say if you want to do something like a route reflector or that, or learning, no, we don't do that. That's not there. But if you want to do sort of route advertisements, you want to go across and spray those packets across, you want to do ECMP, very well you can. There's one more, if you look at this, right, that particular case comes very handy when you're doing SRv6, segmented routing. So that's where this becomes pretty important. And SRv6 is supported by default. That's supported as well. The only reason to highlight that is because when we put that, then people ask, is that not supported? So we assume that if you put this, then V4 will be understood. But yeah, I'll probably make a change to that as well. Yeah, we've not added it, to be honest. It does support it. GoBGP supports it. We've just not added. We are in the process of adding it. The actual plan is to go across and punt it to FRR. Because free range routing is highly scalable, highly capable, has multiple features. But we've added a lot of feature sets from a GoBGP perspective itself. Let's say graceful restart. But then the problem comes is more features coming. You have AS path prepend, you have local pref. So that's where it's better not to explore GoBGP, but go with FRR. Yeah, this all we've already talked about. Let me just go across quickly to, yeah, let's just skip this also. This is all same jargon. We'll see this in the demo as well. Let me go here first and then I'll come back. Yeah, so if you look at this, right, so like I gave that example of the person entering into the airport, right? You can look at somebody at the gate itself asking you to move out because all of your details are wrong. That's where you look at something at a perimeter firewall. We have something called as CCNP or Cilium Cluster Network Policy. Basically, it's a perimeter that you're stopping at the perimeter itself. But then comes the part where you want to go across and define policies which are even more further fine-grained. You want to do across namespaces. You want somebody sitting in namespace A or tenant A not being allowed to talk in tenant B. You can use Cilium network policies. Is that analogous to something what Kubernetes does? Yes. But there are a lot of other things that we add on top of it. Like you have something called as endpoints or selectors in that. Now using those particular selectors, you can have class maps. You can create different class maps. And I'll show that in an example as well. Wherein somebody like, we'll take the example of Star Wars. You have, TIE Fighter, X-Wing and whatnot. And they are being asked to go across and access a different class altogether, which will not be allowed. So that's where the differentiation comes in. This is one thing that I wanted to show. So if you look at from a perspective of how somebody can permeate into a particular network, right? This is a very big blast radius. I mean, if somebody were to enter, right, they can actually just destroy your complete network. Now, how do you mitigate it? Sorry. So basically, I think there was, yeah, we wanted to go across and talk for tetragon. Yeah, I think I made a small mistake here. That's fine. When you would want to compare with what? See, if you were to talk with what he was talking of Calico, that's a different discussion, totally different discussion. But it depends on, see, it all depends on your use cases. What is your specific use case, right? If you're looking at something from a cloud perspective or on a bare metal, it's completely different because in a bare metal, you have more control over your particular hardware. you can, as a very small example, you can go into the BIOS and enable hyperthreading or disable hyperthreading, right? You can add more queues. You can look into the perspective of doing SRIO with DPDK, right? Vis-a-vis something you're doing in the cloud, he will just enable accelerated networking for you, but they will not tell you the particular NIC type that they're giving is just 25 GB capable. When the packets will come back, they will trombone the network, it will get reduced by 1/4, right? So it depends. Now, having said that, we've done multiple sort of tests around that particular flavors or scenarios wherein Cilium has performed far better in terms of different other CNI vendors. Let's take the example of when you were talking about IPsec, right? When you look at IPsec, we've performed far better, but there could be other scenarios where somebody is trying to do something in a very different way, which we've not explored. We will not be doing better. It goes case by case. But on the whole, from a performance perspective, yes, Cilium has done far, far better. Yeah. I didn't get that part. I think you're confusing two things. When you're looking at IPsec, right, that is actually doing your encryption. That's just for your encryption. But when you're, let's say you have one, as a very small example, right? Let's say you have two particular VMs. One is in a different VPC, another is in a different VPC, right? Now these two can either be in a single layer 2 subnet, or the fact they could be in a different layer 3 subnet. If it's a layer 3 subnet, you can actually use BGP, right? Let's leave BGP aside. You can just put in routes, right? Now in that sense, both the VMs are able to talk. We've got nothing to do from a perspective of how we are defining it. What we are saying is that when the agents have to communicate, do you want to use underlay? Do you want to use VXLAN? Do you want to use Geneve? That's the protocol that we are defining. And that gets defined at the time of the cluster being created. But having said that, that's the sort of the onus on the respective cloud provider or the bare metal that you're trying to spin up, right? How does your routing look like? In that sense, that communication is all IP based. But when it comes down to, let's say you have pod A and pod B, you want to encrypt that traffic, right? You can use either IPsec or WireGuard. But the underlying network that you've stitched up is pure IP. That could be running Geneve, that could be running VXLAN, that could be direct or native routing as well. Did I? No. It's got nothing to do with AMQP. AMQP is something that's a use case we can support. It could be a use case that we could support, but not that we are using AMQP. No. We've looked at the fact that you can go across and sort of do networking. You can do security from a network policy of perimeter sort of a policy. But what happens what is running inside your containers? You want to look what are those containers doing. That's where Tetragon comes in the picture. You can actually go and do and don't confuse it with the fact that you are doing scanning of the container like a Falco or a Sysdig kind of a vendor would be doing. We're not doing that. What we are doing is you are actually going across and looking at that particular container and seeing, okay, this guy is trying to do a particular attack type. What is the specific cipher type? What is the sort of the certificate type it is trying to use, and is trying to go across and mismanage that particular not mismanage, is trying to send malicious traffic across to a particular other side. That's what Tetragon does. So if you look at the comparison, right, so in looking for suspicious items, so in this case it's found out that it's actually monitored and see that the TCP CRR is way too higher when Tetragon went ahead and inspected those particular containers. I'll show that in my demo as well, how we can actually look at that particular scenario. Yeah, so the architecture is pretty straightforward. It does the same thing as what Cilium does from a networking perspective. So it just goes across and hooks up to the eBPF kernel. You have these particular pods. It's just an example of app py, app go. It will just go across and look into it. What are these guys doing, and then just print that particular output for any security admin to look at. That okay, this is something which is happening in my network. I need to go across and block it. Let's say you're just doing from a malicious particular container, right? You started doing etc password, which is actually prohibited. You'll be able to figure that out ASAP. And you can block it then and there. Let's say you configured a particular policy. The policy was saying allowed. you can actually go in runtime, click on block, go across and feed that policy back and it will be blocked. Yeah, so this is why is it so, you can do, like I said, inline enforcement, right? So you, rather than something you have to wait, you can actually act on it at runtime. And these are some of the sort of the, the use cases that you can look at. You can have syscall activity, privilege escalations, NS escapes, file access, whatever is there, Tetragon will be able to sort of, expose that in front of you for the security actors. Similar to the Cilium agent, Tetragon agent is also running on every specific node. And similar with the case when you're looking at something, this is what I want to actually show in the demo, and I'll refer to this slide back. And what is actually happening is that this is a demo app which is running. So you can actually see that, it's sending traffic to API Twitter, but there is this malicious guy which is actually doing a curl, which is also being, has actually come out, and we've been able to figure out that this is what is happening. So we can actually block this as well. How this is achieved, you go across and get the logs out from those particular pods and then just push it onto the UI, which can be done via a shell script. And this is what is available to the security admin. I think we already discussed. This is, I think, the best part about the way you observe it. This is, if you look at Hubble or observability slash the product which is Hubble. So if you look at some of these messages, right, you could actually correlate it with TCP dump, right? But this is actually not TCP dump. You're actually looking at the exact flow of what is happening in your particular network. Let's say a client is sending some particular packets to a server, right? You can actually look at those particular packets either on the CLI, or you can actually expose that on a user interface as well. That's what is Hubble. So Hubble CLI is where you can do that on the CLI, and you have Hubble UI, and then you have something for, you can expose these metrics that are achieved from Hubble to either Grafana or Prometheus as well. I think it's about that. Yeah. Same thing. Yeah, this is exactly. So if you look at this, right, so you can see the fact that this is a policy verdict. It's an L4 only policy. It is being allowed. There's all packet types that you can see. You can see SYNs and ACKs, resets being sent by this particular guy. Everything is visible. Can't recall. Yeah, okay. No. But what we can do is we have the ability to write parsers for that. If you write a particular parser, yeah. If you that is something we've added as a support which is available in the enterprise version. That's not available in the open source version. If you let's say even if you're sending encrypted packets, like his example, right, when he was talking about pod A, pod B, right, in this particular VPC to that VPC, and you're sending encrypted traffic, right, there's no way you can see it with this, right. But if you look at the enterprise version, right, that can actually give you the encrypted view as well. But that's not available in the open source version. Yeah, I think there was a question from Santosh. He was very curious to know about it, that how do you get started, and that's something I'll show in my demo as well. But there are a lot of labs that we've prepared. We've put down a lot of effort. These are all free labs. These are labs that you can easily go across and sort of get your hands on with. It starts off with the basics of, let's say, getting started with eBPF to getting started with Cilium, trying out features like egress gateway, L7 proxy, Envoy, whatnot. These are totally free. You just need to go across and put in your name, email address, and then you can get started. I think that's all from my side. Any questions? Happy to.
Any questions?
Yeah. That's right. Yeah. Sorry, can you repeat? With yeah, with EKS anywhere, let's say, I'll break down your question into two parts. With EKS anywhere, we are the default CNI. Default CNI. When it comes down to an EKS cluster, let's say you are going in the marketplace, AWS marketplace, right? Again, will be the default. But when it's a default EKS cluster, right, it will come with AWS VPC CNI. You've got to install Cilium on top of it. No, so that's the good part. You can actually remove the AWS node. You can patch that particular daemon set. It works as a daemon set. You patch the daemon set, you remove the AWS VPC CNI, and you install Cilium on top of it. So then there is no, so in CNI, right, there are concepts of chaining as well. There is a very big concept of chaining, meaning people want to use features from X and features from Y, right? Let's say AWS VPC CNI gives you the ability to do security groups across pods. Something Cilium doesn't do, right? But Cilium gives you L4, L7 load balancing. It does give you MTLS, which this guy doesn't do. So you can chain these two as well. But to come to your question, you need to remove this particular CNI and install this on top of it. Come to Azure, you're doing something called as Azure CNI powered by Cilium, which has now become the default for us, right? It comes by default with Cilium as CNI. GKE v2, you bring up a GKE cluster, comes by default with that. From an open source perspective, we are working very hard that, let's say, even if there is like a micro KATS kind of an environment, right, and somebody wants to bring it up, we want Cilium should be there. When it comes to Minikube, yes, we want Cilium to be there as the default. That's something we are working in the open source community to sort of push through. AFXDP. AFXDP is something we support on Azure, AWS by default. Well, sorry, I mean, it is available. So if you want to try it out, it only depends on the kind of NIC that is there. If you look at, so there are two NIC types. There is Mellanox 4, ML4 and ML5. You got to just make sure that you are booted, your node that you have created, sorry, the cluster you have created is running on a VM, sorry, on an instance type which supports those particular NICs. And the kernel as well. Kernel has to be 519 above.
I just want to agree with what he said about the labs. I have tried 3 or 4 of them, really good, very well made. A lot of effort has gone to that, and it works really well. And I think quite a few would have tried that. Some of them are really, really interesting. So if you haven't, please go back and please give it a shot on that. Okay.
Yeah,
Thanks a lot, Amit.